Alright, boys and girls, it's time for video 7.3. And hope you're enjoying your spring break. I'm guessing that it's Monday night if you're watching this, and we're going back to school on Tuesday. But if you're working ahead of the game, that's all the better. Make sure you jot down some things. There's a lot of information in this particular video, but I want to hit the highlights. I want you to remember certain things about each one of these chemicals. We are on page 471 in the textbook, and there are certain key chemicals that always get brought up on the AP and ACE exams, and we're going to go through those in particular. First of all, there are classifications of chemicals, and the first one we've already talked about a lot, and that is neurotoxins. Neurotoxins are toxic. You can tell from the name, they are toxic to the brain and to the central nervous system. And the worst ones, we've already learned them, are mercury and lead. Mercury and lead. And if you haven't committed this one to memory yet, please do so. Minamata's disease is that disease of a buildup of mercury in your bloodstream. Alright, so those are the ones that affect the nervous system. Then we have carcinogens. You know, gen at the end of anything means it's the cause of or the beginning of, you know, like Genesis in the Bible. So carcinogens are cancer causers. We've already learned that before. But you haven't learned this one. They are called teratogens. And teratogens are chemicals that affect the fetus inside the mama before birth. Teratogens therefore cause birth defects that happen after a while. Look, even alcohol can be considered a teratogen. There is a reason why women are told not to drink alcohol during pregnancy. And this idea is pretty simple. You never know when that developing embryo and then later, you know, becomes a fetus. You never know when the cellular replications are happening in your body as a female. You never know when the generalized cells are going to differentiate. We call them stem cells. That these stem cells are going to differentiate and become part of the digestive system or part of the nervous system or, you know, part of all the different organ systems that we have in the human body. If you happen to introduce to the developing embryo or later the fetus one of these chemicals at the most inopportune time, right during these cellular divisions, then something can go haywire and we end up with a birth defect. Allergens are chemicals that cause you to have an allergic reaction. You know, pollen is an allergen. I'm dealing with that right now. For whatever reason, I never had this problem younger in life, but the last few years when it's this high pollen season, like right now, it really kicks my immune system into overdrive and I start producing way too much phlegm and all that other stuff. Endocrine disruptors are particular chemicals that we are finding now in the ecosystem, and what they're doing is they're affecting the endocrine system. And do you know what chemicals the endocrine system makes and is responsible for? Those chemicals are called hormones. So in organisms that require hormones in their growth and development, and almost all do, especially the mammals, these hormones get disrupted. And the way that works is the chemical that doesn't belong in the environment is mimicking the actual hormone, and it disrupts the activities. So there's your different types. Now I'm going to go through some very specific chemicals that are particularly dangerous. First, you've got this list of them on page 472 in your book and their sources. And we've covered a lot of these already. We've already done lead. We've already done mercury. You should know these sources. You should be able to make most of this chart yourself. They're neurotoxins, right? Arsenic we've talked about in terms of it being in drinking water, and I've got a little video to show you about arsenic. Asbestos we've talked about. PCBs we've talked about. PCBs are used in the making of circuit boards, and I'll tell you what, I don't think there's an electronic device that you can name that doesn't have some sort of circuit board in it. We've already talked about radon. We have not talked about vinyl chloride. We have talked about alcohol a little bit already, and we'll talk more about it in class. We've talked about DDT. I've never seen atrazine or these phthalates tested on your exams, but it's because they're pretty new. And notice what they are. They are endocrine disruptors. You remember the story about DDT. That endocrine disruptor caused the thinning of the eggshells of birds, and therefore the species couldn't handle it very well, and their numbers went way down. All right, here is the little story about arsenic.
Are a problem in many parts of the world, but especially in the developing country of Bangladesh. Bangladesh, one of the least developed countries in the world, has some 40 million or more people that are being exposed to toxic levels of arsenic found in many of the nation's 6 million private and public wells. Arsenic can poison its victim over time by accumulating in the liver, spleen, kidney, and lungs in a condition known as arsenicosis. The situation in Bangladesh is compounded by environmental pressures on local resources, resulting from a population density that is more than 30 times that of the United States. For example, intense rice cultivation has resulted in the excessive extraction of groundwater for irrigation, thus lowering the water table in some areas. The lowering of water tables may be the cause of the arsenic contamination in some wells. Arsenic sulfide minerals, which are relatively insoluble in water, naturally occur in local sediments. When the water table is lowered, the arsenic in the sulfides becomes oxidized to a form that is more readily soluble in water. The oxidized form of arsenic are then dissolved by percolating rainwater, which contaminates an underlying aquifer that supplies a nearby well. Ironically, over 90% of the population lives within 200 meters of a safe well. Yet social obstacles and private property boundaries prevent millions of people from using safe water from a neighbor's well. The challenge remains to find a way to provide the millions of people at risk in Bangladesh with an acceptable alternative source of clean, arsenic-free drinking water.
All right, for your usages, the important things to remember about arsenic is that it's a drinking water contaminant. It's inorganic, naturally occurring in rocks, and you can see how it forms. It's not so much a problem in our country as it is in other developing countries, but arsenic is an issue, and that's why it's covered in this chapter. All right, let's talk about lead. We've hit all of these things, I think, already about lead, so I shouldn't have to spend a lot of time on them. Lead poisoning is a major problem in children, right? And again, because they're not very clean and they'll put crazy things into their mouths. The primary sources of lead back in the day, leaded gasoline. Now see, in other countries there still is leaded gasoline, so remember, this is a worldwide problem. Lead in paint, there's lead in plastics, and there's still some lead in the solder that's used in copper plumbing. We're doing a very good job in reducing lead, at least here in the United States. Now that the dangers are well known and we can measure it in children, many times when a child has a problem, we'll do lead testing on them. We'll actually do lead levels on their blood to see if that's a contributing factor to a child's lethargy or a learning disability or something along those lines. Lead can be found in a lot of different things, and so that's why a pregnant woman needs to be careful about her unborn baby when it comes to lead. Should not be handling a lot of ceramic materials because there can still be lead in some of those ceramic paints. There can be lead in dust, there's lead in paint, you get the idea. Lead in the water lines. So this lead can accumulate not unlike how mercury accumulates and can be a neurotoxin. This graphic here just shows you how successful we have been, and you can see it was not all that long ago where the lead levels that were found in the bloodstream of many children was very high. Not so much now. As we move on, we've done a very good job of decreasing the amount of lead levels found in people's blood. Okay, that's lead. Let's move on to mercury. You know, I've talked a lot about mercury, the liquid version of mercury that the teacher played with when she was in elementary school. That is one problem. But the most common problem that we're finding inside of the ecosystem is vaporized elemental mercury. And this vaporized mercury ends up in the air when you burn coal. Scrubbers are designed to take the mercury out of what comes out of the smokestack at a coal burning power plant. Doesn't always work. I'll show you the diagram in a minute, but this elemental mercury, which means it's just plain old Hg, will react with other compounds though, and when elemental mercury reacts with other organic compounds, it becomes methyl mercury, and this is the form of mercury that is found in the fish population. Remember, we've talked about mercury as an example of biomagnification. It goes up the food chain. So when tiny fish when small fish eat tiny fish and bigger fish eat small fish and the biggest fish, by that time in the food chain, this methyl mercury has really accumulated in the tissue of the large fish. So people need to be very careful when they consume large amounts of large fish especially. And this is a problem in societies where they have a lot of fish in their diet. There are some natural inputs of mercury that end up in the ecosystem, and we can control emissions of mercury, but we have to do a better job. And once again, if you're in a developing country and you're burning coal for your electricity in your cities, you're probably not doing a good enough job of taking the mercury out of what comes through the smokestack. This diagram here kind of shows you how mercury operates in the ecosystem. Here's what I want you to remember. I want you to remember elemental mercury vapor is in the air. All right, it's in the air from the coal burning power plant, probably from, if we burn our trash, the incinerator. All right, so now the mercury's in the air and it's vapor. So it can react with a wide variety of things. It can react photochemically and get into the precipitation and end up in water systems. But here's what I want you to remember. I want you to remember that this elemental mercury will react with organic compounds. Notice the CH3 here. This is called methyl mercury. This organic mercury is the kind of mercury that ends up going up the food chain. Biomagnification. Biomagnification. Okay, so all of this busy slide, and all I've done really is zero in for you what? 1, 2, 3, 4, 5 things I've boxed for you or circled. That's it. That's the most important things for you to remember about this slide. I think that's all there is about mercury. So now let's talk about chlorine. Chlorine can be a very, very dangerous chemical. It is explosive when it's held in large concentrations and large amounts. For instance, if you have a container of chlorine, really large, like the size of a water tower type of thing, that chlorine can be very, very dangerous. Chlorine vapor, just breathing the fumes of chlorine can burn your respiratory tract. Just breathing in chlorine gas. Just breathing in the chlorine gas burns your respiratory tract. So it has a potential to damage human health. And we all know why we use chlorine in our daily lives. We use it to kill bacteria. We use it to kill bacteria in our pools. We use it to kill bacteria in our laundry in the form of bleach. So we use chlorine a lot. And when you put bleach in with your laundry, where do you think that bleach ends up? It goes down the drain and it ends up at the water treatment facility. If we end up with too much chlorine in our water supply, we do real damage to the living things, because if it can kill bacteria, it can certainly kill other living things. If you drank some bleach, good way to die. Chlorine, bad for you. All right, so many plastics use chlorine in their manufacture, and it's not that plastics are going to be a danger to you now, but if they break down, like in the landfill, when plastics break down, they will release chlorine into the ecosystem. We use chlorine in a wide variety of our own products as a solvent, as something to help break things down. The pulp paper industry uses bleaching extensively to get all of the ink and things off of that paper so that they can recycle it. Obviously, they're under very strict federal guidelines as to what they're allowed to do with that chlorinated water as part of their processing. Most pulp paper places actually reuse their bleach again and again. They actually have a chlorine cleaning part of their operation. And of course, we use chlorine as water disinfection. And the point here is there are many safer and cheaper substitutes for chlorine. Yet right here in Clay County, where we get our drinking water, we're still using chlorine and added chlorine. Fluorine is a better option. And in fact, a lot of states are using fluorine. Remember, fluorine is on the same column of the periodic table as chlorine is. It's a 7A. So fluoride has many of the same chemical attributes as the chlorine does. For instance, fluoride will kill bacteria. So what a lot of states have done is they've added fluoride to the drinking water rather than chlorine. It kills the bacteria, but there's an added benefit. Fluoride is good for your teeth. And in many states they add fluoride. It has the added benefit of helping your teeth stay strong and cut down on those cavities. All right, here's a new one, dioxins and furans. You've never heard of furans before, but you need to memorize both of these. These are the latest bad news bears when it comes to the environment. Highly toxic. They are called chlorinated hydrocarbons. These are, there are 8 specific chemicals. Dioxin and furan is a class of chemical like hydrocarbon, like I don't know. I'm drawing a blank, but these are a classification. So there's lots of different chemicals in these groups, and there are 8 dioxins that have been banned worldwide. They were frequently used in manufacturing products. So once they got banned, then we needed to worry about where else dioxins are coming from. And we're finding that they're released when we burn waste, when we burn wood, that there are dioxins in these that are in coal. So our so-called biomass type of things here and our non-renewable energy sources, fossil fuels, have dioxins in them. Again, only dangerous when it is burned. And dioxins are used in paper production. What do you need to know about these? You need to know that they are a chlorinated hydrocarbon, and you need to know that they are the latest really, really bad chemical found in the environment. I'll show you this video in class, so you'll have to remind me to do that. Oh, also found in sewage sludge. All right, teratogens. Teratogens aren't just chemicals that might be ingested, but they are also drugs. Drugs that have been actually used on the market. And one of the famous stories about a teratogen, tragic story, was back in the 50s, a drug called thalidomide. Now this drug was prescribed for women who were having morning sickness. So they knew they were pregnant, but they knew they were nauseous and they had some vomiting and all. So OBGYN doctors in England would prescribe thalidomide. 9 months later, or 8 or 7 months later, when the babies were born, they had a very characteristic birth defect. Their arms were too short and missing fingers. This was also a problem here in the United States, and through a lot of investigation, finally discovered that this drug, a routinely used drug for nausea, was causing birth defects. That is the definition of a teratogen. Like I said, alcohol is a teratogen. It can cause birth defects in babies, and that's why moms are encouraged not to drink during their pregnancy. Mercury can have an effect on the mom as well. Women are discouraged from eating fish during their pregnancy just because there might be some mercury in that fish. Who wants to take the chance? I mean, chances are there's no mercury in that fish that you eat tonight at Bonefish. But who wants to take the chance? Chances are you could have a drink and the baby that's developing inside of you is not having one of those key cellular division moments. But who wants to take the chance? And the last one was endocrine disruptor. This diagram here just shows you how it works. The chemical looks just like a hormone, and it attaches to a cell and it blocks the normal creation of the hormone that's being produced. In this case that we're talking about here, estrogen is converted to testosterone and male features develop normally. Now we're not talking about humans here. We're talking about many different species of organisms. But these endocrine disruptors are mostly in the water, so our big discovery about endocrine disruptors has been in amphibious populations and fish populations. Anyway, it works the same way. The problem is, this is how things should normally end up, but the endocrine disruptor attaches to the receptor but doesn't trigger the correct response. And so estrogen is not converted to testosterone, and males end up with low sperm counts, may even end up developing eggs in their testes instead of sperm. So we have discovered these rare anomalies, as I said, mostly in the amphibians and in the fish populations. All right, well, I think that is it for the chemicals. We've covered lead, we've covered mercury, we've covered thalidomide, we've covered the infectious diseases in the last video. Now it's time for us to launch into video 7.4, and this is how we determine what the right concentration level that's acceptable is for humans. So that's called dose response studies, and I'll save that for the next video. Take care, and I'll see you soon back in school. Again, hope you had a great break.